My name is François Doremieux, together with Adam Gent, who is still in the pits here doing real-time optimizations of layer 1 stuff. We're going to be talking with you about interoperability. We've been giving, Adam and I, discussions on interoperability for the past 2 editions of TechEd, both in the US and in Europe. So we're not going to go into every aspect of detail of everything we do in interoperability. We'll refer you to some of the past documentation and other type of documentation. We'll spend a lot of time on 2 domains of interop, video rooms and IP-PBX interop. And if we are lucky, in about a half hour, we'll have something working here, and we'll be able to actually do quite interesting demos that have never been done or never been shown before. I'll start with just very briefly indicating where you can find more about what we do in interoperability, about how we do interoperability. And I have conveniently put links in the deck so you can actually go click and look at past discussions as well. We've actually spent a lot of time in previous presentations on what we do in terms of principles, how we engage, how we use interoperability as a key principle of our development. So I won't go back on it today. How we support a rich, as in heavy clients, strategy on a variety of platforms, in particular Windows and Mac, and a rich approach on other types of platforms using web applications. So I won't do this in detail here again. We've spoken about IAM and presence interoperability, XMPP gateways. So same thing, not going to detail this. And we've spoken about our third-party interoperability program for phones, which in particular the SNOM 300 phone has been qualified through. There's also the Open Interoperability Program, which is a program under which our partners, in particular gateways of available branch appliance partners, and IP-PBX partners can, and telecommunication service provider for SIP trunking and a few other things, can qualify their solutions and ensure that we have supportability end-to-end for their solutions. Again, I won't be detailing this, but you have a lot of those references here. One last point, which is the UCIF, Unified Communication Interoperability Forum, which was announced and funded just about a year ago, I think, which is actually quite successful in helping the industry come together and have better interoperability. Some of the key aspects in which they're working and making a lot of progress include video interoperability, so we'll refer to that in a second. With this, we'll get into the little bit more exciting, more interesting part of the discussion and talk about video room systems interoperability. Our strategy with respect to video really combines 3 key elements. The first one is desktop video. Desktop video is a very, very important, critical aspect of what differentiates our approach as compared to traditional legacy approaches in the video space, where rooms were at the center of everything. Rooms are still important, and we'll talk about that, and we'll talk about how we interoperate with them. But really, we see the future of video as incorporating more and more desktop video. Right now, it's possibly still a bit of desktop video participating in room system meetings. More and more, it's going to be about room system meetings, room system participating in desktop video meetings. So having that ability of having fluent conversation between the 2 systems is important, but centering capabilities around desktop video is what we really want to start from. So we provide, as you know, high resolution, high definition, those kind of things, which are at the core of our offering. We're also working with partners in improving the meeting room experience, and that's what we're going to concentrate the rest of this discussion, in particular around interoperability. And in so doing, I'm pleased to officialize, even though it's probably something that you might have heard before, the announcement of a video interoperability program. That video interoperability program has been in place for actually a few months, but it's not been formally announced in a setting like this one, so I'm pleased to do so. And I'm going to tell you what it entails. The purpose of the video interoperability program is really to allow our customers to use their systems, their room systems, and Lync in a manner that enables clear and easy interoperability between the two. There's different mechanisms that we support in that aspect, and I'll detail that a little bit more, and we'll see examples and demos of those different approaches. The first one is direct registration. So when a partner solution, either a room or an MCU, which is a mixing, or essentially a mixing unit, so a video mixing unit, when those systems want to talk to Lync, they can register as if they were a Lync client. I'm oversimplifying, it's a little bit more complex than that, but they can register as if they were a Lync client, and then they're part of the Lync system. They can do video, audio, those kind of things with that system. So that's the direct registration. The second capability, or the second mode that we support, is gateway-based, and that entails having one system and Lync being connected by a gateway, and the gateway essentially serves as go-between between the two. We have programs and capabilities to support those two approaches, and we have partners in those two approaches. I'm going to show you a little bit more about that in a second. We have a process and documentation, all those things, and the requirements are actually quite important. We have two levels. You can be qualified at the OCS 2007 R2 level, which is kind of a legacy level, if you will. That's a relatively basic solution in which we are mostly aiming at point-to-point collaboration at a level of quality that may not necessarily be very advanced from a video quality point of view. Typically CIF video, H.263. So that type of interoperability is functional, but it's probably not going to give you the broadest range of capabilities, if you will. The second level, which is at the Lync 2010 level of qualification, adds to that support for high definition or VGA codec resolutions and multi-party video on the Lync MCU. We'll detail that a little bit more, and we'll see examples of that. But essentially, that enables a room system to participate on a multi-party video where the mixing unit is no longer the hardware unit, the legacy hardware unit, but could be the Lync MCU. This is not a question of saying, that it's the only way to do it. It's one of the new options that are provided. So you can actually continue to use your hardware MCU if you want to. You don't have to switch to Lync MCU, but it's a new option. And we'll see in a second what type of benefits you can derive from that. At a little bit more granular level of detail, these are some of the technical requirements that we're talking about. If you look at the green box here, the green box essentially, and it's part of that OCS 2007 R2 level, the green box essentially just supports peer-to-peer calls at the lowest level of resolution possible, CIF. But we do require that some security aspects and some registration aspects would be covered. So in particular, we need the third party to use SIP, encrypted SIP, so to TLS to us, to authenticate either directly or through the use of a trusted server, so directly using NTLM or using a trusted server type of approach. To support wideband audio to provide the best possible quality for audio, could be RT audio, could be G722. As we said, lowest level of video codec capability, which is H.263, not great, but functional. And we also would like for that room to be able to publish its presence, so we know whether it's available or not to you to go into a conference. Most of the partners that we've worked with, that we're working with, already are at that level at the very least. Many are further along, but most of them are at least at that level. The second level enables somebody who would be using Lync, for example, to have a video session with a room, even when, let's say, they're working from home. You were supposed to be in the office, you're sick, you want to be participating remotely. You use Lync, go securely across the firewall using ICE, and encryption of your media so that nobody eavesdrops on what you're saying. So that second level is also something that most partners are either in the process of implementing or have implemented. The third level is where you actually get a lot of very nice things. You get much better resolution on a video point of view, VGA or high definition. And you also get something called CCCP, which is a protocol for conferencing that enables you to create multi-party sessions on the Lync MCU. For example, you could actually drag and drop the contact object, the object that represents the conference, the meeting room, the physical meeting room. Let's say you have a Tandberg meeting room. You could drag and drop that object into your Lync contact conversation window and get to a multi-party session and have a three-way call, including the conference room. We'll see that in a demo in a second. This is a stage at which less partners have arrived yet, but most partners are in the process of implementing. So we have those two type of approach, direct registration and gateway/MCU. And at this point, there are at least 3 partners that are in the program officially, Polycom, Lifesize, and Right Vision, that are providing capabilities along those different aspects. Polycom and Lifesize are working on the direct registration program, and that enables your video room to register directly to Lync and to have those multi-party call when the CCP is implemented. And you can really have all the continuity of all the capabilities there. On the other side, gateway/MCU, both Polycom, Lifesize, and Right Vision, but in particular, Right Vision is specific to the gateway aspect, provide this type of capabilities. If you attended Kirk Gregerson's presentation on, I think it was on Monday afternoon, if I'm not mistaken, you might have seen Kirk demonstrate one of those type of capabilities with the MCU from Right Vision, from Polycom, sorry, my apologies. We're actually going to show the capabilities of another partner in a second. A question that comes up very, very frequently is, what about Cisco telepresence? Who wanted to ask that question here? Yes, there's a few hands, yep. So what about Cisco telepresence? Cisco and Tandberg we talk and communicate a lot with them. At this point, we are not yet in a position that we have a solution that is something that we've completed evaluation on in any manner. There is something in process on the OCS 2007 R2 level, so at the little bit simpler level that we described earlier. As it pertains to Lync, I cannot give you a situation, unfortunately. I recommend that you ask what Tandberg's plans would be in this space. That said, we know that they have a solution that they might present to customers. And I would like to talk a little bit about what that solution is. It's a solution that's based on several boxes. One is a gateway that's used for signaling called VCS. And then they have an advanced media gateway which does media transcoding, typically would transcode between H.264 baseline and RT audio. If you want to get high definition video, you need those 2 gateways to start with. And then if you want to go across a firewall, they have another solution which requires 2 more VCX boxes. At this point, Microsoft has not evaluated, Tandberg and Cisco have not approached Microsoft to participate at the Lync level in this situation. And so we cannot recommend that solution, but we do have alternatives which we recommend strongly and which we are going to demonstrate in a few minutes. So the recommended approach that we have at this point in time would be to use one of the gateway partners or MCU partners, Polycom or Right Vision. And we're going to show that in the case of Right Vision in a short while. So we'll do a demo of gateway-based, Right Vision Scopia gateway-based interoperability with Lync in a second. Let me tell you a little bit what we're going to show you so you have a sense for how that works. So if you look at the left-hand side, we'll have either one or multiple H.323 endpoints. In the most advanced demo, we'll actually have 6 endpoints. I think there's going to be a Tandberg, a Lifesize, a Polycom, a Right Vision, Cisco telepresence, whatever. There's going to be a wide range of them, so you can actually see all of those. But you could have only one or multiple endpoints here. You're going to have the Right Vision gateway, and on the side of Lync, of course, a Lync client and the Lync server. The Lync client, of course, talks to the Lync server, and the Lync server is going to send signaling to the Right Vision gateway the Lync client will send its video, its media to the gateway. The gateway will then transcode that to H.264, which is the codec that's going to be supported by the H.323 endpoint. And it's also going to intermediate the signaling between SIP and H.323. So that's in the case of point-to-point calls. You could also do a multi-point call on the Lync AV MCU, and that's supported. So in this case, if you escalate the call from point-to-point to multi-point by, for example, dragging a third person in the Lync client window, you actually have the call encoded on the Lync AV MCU. That's actually a quite new concept in which case you could have multi-video capabilities without a hardware MCU, and that's already available today. So no hardware MCU, multi-party calls possible. Those multi-party, by the way, could be multiple H.323 rooms or could be multiple Lync clients. Doesn't really matter. Okay? Which brings me, I think, to the demo. Yes. Need to log back in the machine. Would you press on C, please? Okay. So here we have a Lync client, and I'm actually showing here on my contact list contacts that are actually either physical conference rooms, that's the main conference room on top, NJ main conference room, or actually a virtual room, which is a virtual room on an MCU that's behind the gateway. We're going to start with a call with the main conference room here. And the way I establish a call with it is exactly the same thing as establishing a call with any other Lync contact. I started this, and I'm actually going to go into a video call with it. So my video is established, and we should see Yoav on the other side fairly soon. Okay, I think we're seeing Yoav here. Going to go full screen. Hello, Yoav. How are you doing?
Hi. Hi, I'm fine. How are you?
I'm very good. Can you tell us where you are and what we're seeing here?
Yeah, hi. I'm sitting in a New Jersey conference room. I'm using VTC room system, and I'm connecting using the Scopia UC gateway to the Microsoft Lync.
Very good. Well, Yoav, thanks very much. We'll see you very soon again on the virtual room.
Okay, thank you.
So that's a live call using a Right Vision gateway, point-to-point, between a physical room, which was using a traditional VTC system, H.323, to Lync. Very simple. Now I'm going to switch back to, I think this would be A. Would be logical if it was A. Yeah, it's A. Good. Now the next thing we're going to show you is a situation where you actually have a MCU on the hardware side. Let's say you have multiple rooms and you want to do a variety of things. You might want to show multiple views of the different video rooms at once, that multiple view Brady Bunch type of thing. The hardware MCU can support that, or you might need some specific features or capabilities of the hardware MCU. You have it there. So the hardware MCU this time is connected behind the gateway, behind the Right Vision gateway. That's the only difference here, knowing as well that we could also do something like this. You could actually have a conference for all the desktop participants on the software MCU that enables you high scalability and something that's a much lower cost than using hardware MCU ports. So you could have, let's say 100 video ports on the on the software MCU. Then you could have a number of rooms on the hardware side, all talking to each other, and you only need essentially one port on the Right Vision gateway in that case. So it's multiplexing, if you will. And in this specific case, what we're going to demonstrate is interoperability with this broad range of systems that I mentioned before: Right Vision telepresence, Cisco telepresence, Right Vision VC, life-size room, Polycom room, Tenberg, and another Right Vision there. Okay. So I'm going to hit C again here. And we're going to call into the virtual room. Let me maximize. Okay, Yoav, we see you again. Where are you now? It seems like you changed rooms.
Hi. Yeah, okay. I have moved to our telepresence room. I'm connected to the telepresence room, and the telepresence room is connected to our virtual room. To the virtual room, we have several other endpoints connected. We have a Cisco CTS 3000, Tandberg C20, life-size endpoint, Polycom. And we can see you connected from your link. Okay.
Yeah, we have a little bit of echo in the room. Can you please maybe lower a little bit the volume? Or maybe mute my microphone temporarily, whichever it is. There's too many microphones in this room. Okay, you can continue if you want.
Okay, so I'm, by the way, maybe you can mute so you won't get echo while I'm speaking. So I'm sitting at New Jersey telepresence room. This is a Rad Vision customized telepresence room. To the conference, we have several other endpoints. Okay, but you can explain.
Yeah, thanks very much. The sound quality here in the room is pretty bad, unfortunately. It's nothing to do with the solution itself. It's just the aspect of the room. So thank you very much for your time. And apparently people are leaving work now. It seems like it's time. So thanks a lot, Yoav.
Thank you. Bye.
Bye. Okay, back to A. And just to show you that it's not just like a gadget that is pre-release. Well, actually, it's partially underway still, but it's actually deployed in production. We have a customer somewhere waiting in France, whatever time it is in France. It's like almost midnight or 11 p.m. To actually tell us how it's working for them. So let me bring Yannick from Crédit Agricole. Bonjour Yannick.
Bonjour François.
Hello, you're actually speaking to a very large room of people here. How are you doing tonight?
Fine, thank you.
Can you tell us a little bit about who you are and how comes you're involved in discussions about video interoperability with Lync?
Yes, I'm working in Crédit Agricole in the innovation division, and we are working to innovate in all the different requirements of the bank. We work on a solution to solve a problem we had from a while. We have Lync deployed as a company, and we have a lot of Rad Vision, no, not Rad Vision, Tandberg room system in many locations. And the big challenge was how to make users to participate to meetings from Lync clients on Tandberg room systems. This was required for a long time. And we work recently on a solution with Rad Vision. And it's working very well from since 1 month with all the functionality. It's connected to an operational environment. We have meetings going on between the two systems. And users are happy with that. And we are pretty, at the current stage of the evaluation, we are very satisfied.
Very good. Well, thanks very much, Yannick. I apologize for keeping you up so late. It was great seeing you, and I will owe you something like a very good dinner in France one of those days.
Thank you very much. Have a nice day. Bye-bye.
Thank you. Bye-bye.
Bye.
Poor Yannick stayed up apparently in the office until 11 p.m. So that's to tell you that we actually have production deployments today of this type of solutions working very well, as you could see, have a lot of rich capabilities, and actually quite interesting from a cost point of view. With this, what I suggest is we could do a quick Q&A on video questions only right now, and then we'll switch to IP-PBX interoperability. Any questions on video at this point in time? Would you mind going to the, yeah, I apologize for this, but otherwise people won't get it.
Sorry, when you're actually doing a peer-to-peer video conference call, can you switch directly to a multi-party with seamless interaction?
If the partner has implemented CCCP, which is the appropriate portions, not necessarily everything in CCCP, but if the partner is capable of supporting the conferencing protocol, then we can drag and drop that party. I could have actually shown that. We could have dragged that, I could have taken Adam's contact, dragged it into the conference that we were having, and create a tied conference. There could have been a conference on the hardware MCU, conference on the Lync MCU, and the two would have spoken to each other. Yes, absolutely.
What video resolution did we see here?
I believe we saw, well, this was point to point, so it has the potential to be 720p, HD 720p. Yeah. I'm not sure whether that's what we saw. It's difficult to know exactly, but it has the potential for being that. Okay? We can talk more about video later, but I just wanted to make sure if you had some questions on your mind right now that we would do this. Then we're going to start, we're going to switch gears a little bit and talk a little bit about IP-PBX interoperability. And as you see, we have some goodies here, and we'll have a lot of fun with that. Assuming it works now. Yeah.
It seems to.
Good. Should we do a demo right now? So the first thing we want to talk a little bit about is media bypass in Lync 2010. Media bypass is a super critical feature when it comes to IP-PBX interoperability. In previous decades, we've talked at length about direct SIP and how you can interoperate, creating a SIP trunk between the systems. I'm assuming that people have some understanding of that. And if you don't, it's detailed in great level in the previous previous decks that I linked to. What we're going to talk about now is one more layer of complexity, or simplicity in a way, which is called media bypass, and we're going to explain what that is. It's a variation on the SIP interconnectivity between systems. I'll start with talking about one of the pain points that we had in OCS 2007 R2. While we actually had a very large range of interoperability capabilities, both through PSTN gateways or direct SIP from OCS to an IP-PBX, that type of interoperability required routing the media through a server at the time, which was called the mediation server. That meant that if you needed to connect two systems, you already had a server in the middle, a Microsoft server in the middle. In central sites, typically, even though it was a bit more cost, it was not a big deal because you could manage that in data center. That was okay. But where it became very complex was in branch deployments, because if you wanted to deploy in branches and you had to put a server every time in every branch, it was both costly and difficult to manage, and sometimes not in conformance with security requirements. So another way would be to not deploy the media server there, but then what would happen is the media, if Adam would be on, let's call that Cisco, and I would be on Communicator R2, in the same branch, and we would talk to each other, the media would have to go to the data center and back down. So tromboning of the media every time. It's kind of ugly and costs money, and it's not ideal. So that was a major pain point, and that's kind of represented on this chart here. I have a laser pointer somewhere. I think that's the one. Yeah, and that's the mediation server in question. So if you're in the branch, if you think of those guys, this one and this one being in the same branch, just on different systems, you have to go all the way to the one to the data center back down. In Lync, we introduced media. Sit down. Thanks. Kind of going around every time. In Lync, we introduced media bypass, which means that the media can flow in the appropriate circumstances. We'll detail that directly from the Lync endpoint to the IP-PBX and thereon to the PBX endpoint, without having to go through the mediation server. One one value that we derive from that is that the mediation server, which is still used for signaling intermediation, now doesn't do nearly as much effort, CPU cycles, transcoding, these kind of things, and can be collocated with the Lync front-end servers. So you actually have a reduction in server count, and you have less media intermediation. It's a much cleaner situation. We're going to detail that and see how that works, and we're going to actually provision this under your very eyes on topology with Cisco Call Manager. A little bit more detail on how this works and the benefits. So we keep the signaling intermediation, and one of the reasons is that creates a layer of both standardization for the signaling, enables a much more standard type of interoperability on the outside edge. This also can be considered a security mark, so it's quite important. On the other hand, not having the mediation server as a media hub really enables latency reduction. It provides you better control over which codec you select, particularly being able to talk directly in G711 to the other system. So you can actually have a much better situation. We will also see media resiliency. We'll at some point show you that if the mediation server was to die, you would actually still keep your call up. So it's actually a much better situation. How it works is that bypass only occurs if the Lync client is local to the PBX next hub. We don't want to have a situation in which the Lync client would be on the other side of the world, the media would arrive, for example, across the internet, would be all chopped up, and then it would go directly to the IP PBX. Why? Because we need to do media healing. That's part of the qualities of Lync, to have a media stack that's capable of healing that media and making it correcting any issues that we would have, packet drops and so on. So we do keep that media healing capability if the client is not local. Okay? But otherwise, we go straight with G711. Okay? So as I mentioned, one of the benefits is that you can have a lightweight mediation server, and in particular, that mediation server can become a service, and that service can now be embedded in the survivable branch appliance, which is some sort of a super gateway, if you will, from our partners. And that survivable branch appliance has the mediation service there. Rather than having to churn to transcode each and every call that goes through it, it actually transcodes a small proportion of it, so it actually fits within the box without any scalability issues. Getting a little bit more technical here, how it works is that you have two approaches. One is a situation in which you have, for example, only one site. If you have only one site, or if you consider that your deployment has good enough connectivity that you want to treat it as only one site, you're going to select always bypass in the global settings on the Lync control panel. At that time, you have a single site. Of course, it means that you cannot have call emission control. Call emission control is almost by definition that you need to have multiple sites and do call emission control between them. And at that point, we will always bypass to the trunks that are enabled for bypass. The second capability, or the second way of doing it, is much more discrete. You're going to decide the sites in which the bypass will occur, and of course, between those sites, we'll have a WAN, and bypass will not occur across those WANs. So that's using site and region configuration. And the way you do this is that you leverage the topology information. That's the same topology information for the network topology in Lync that we use for call emission control. So we use regions on site definitions, and you need to have a bandwidth policy profile. And once you have that, we actually calculate something which is called a bypass ID. That bypass ID is allocated to a site. Something that's really, really interesting is that we actually have the ability to do this dynamically. You take your laptop, and you're in headquarters. You have a bypass ID that's specific to where you are at this point in time. You take the same laptop, you go to Atlanta, and now you have a different bypass ID. So we'll do bypass dynamically based on where you take your laptop, which is a very interesting capability of the system. So we're trying to optimize the media, not just based on where it is you're supposed to be, where your phone is, if you will, but where you're actually at. So the way this goes is the client IP address will then generate a bypass ID, or the system will generate a bypass ID that's associated to the client IP address based on the subnets that the site represents. The gateway does the same thing, and then we will do the bypass if the bypass IDs match. Essentially, that means you're on the same site, on the same subnets, if you will. We'll see that in a second in the demo. And that's the representation graphically of how this works. You can, if you enable call emission control, then you cannot have the always bypass. As I mentioned, that's kind of, those are mutually exclusive. But you can have use sites and region configuration, and then you'll do bypass side by side. Okay? There's two different logics, or there's slightly different aspects to logic in terms of how the bypass works. When you're having inbound calls, the invite comes from the outside. The mediation server receives the invite. At that point, it's going to look in the SDP for the IP address of the media gateway, because the other party is going to send us the place that they want us to send, that they want the media to go to, or to come from. And we're going to take that IP address from the SDP, which may not be the same IP address as the signaling gateway. You can have a centralized call processing server that has multiple media endpoints, multiple MTPs, multiple media gateways. And that's a very important aspect. That aspect enables us to talk to the same signaling gateway all the time through a SIP trunk, but then send the media or receive the media from different media endpoints, which will come in the SDP. The mediation server will compute the bypass ID. It puts it in the SDP that it then sends to the client. And then the client will make the decision as to whether it bypasses based on where it is. Based on its own bypass ID, it gets its bypass ID from the inbound provisioning. From an outbound call point of view, it's a little bit similar, but the reverse way. And the decision is going to be made by the mediation server. The client is going to put its bypass ID in the SDP. The mediation server is going to find the gateway based on what call you want to place, and it's going to determine the bypass ID of the gateway in question. It has the ability to use a representative media IP, which is something that you put in the configuration. We'll see Adam do that in a minute to do that. So we don't need to know the exact IP address of those media gateways. That's interesting because if you're, let's say your Cisco team is changing those IP addresses all the time because they're rearranging things, but it's still in the same subnet, you don't need to keep up with that all the time and kind of go reprovision it in the system. And then it's going to make the bypass decision based again on whether the ID match. With this, I think we're getting very close to seeing it in action. Before that, just a reference, I encourage you to look at the OIP page, which is probably much more up-to-date than this. But those are kind of the PBXs, IPPBX, gateways, and survivable branch appliances that we're testing. Of course, all of our partners in survivable branch appliance space, including those that I honor here in the room, have qualified in that regard. There's a number of other gateways that are being tested. Some of them will work with bypass, some of them not. Some of them, there's configuration notes, so I encourage you to look at that. If you have a choice, I certainly strongly recommend you use the approved partners and SBS for that. And then IPPBXs, we have a long list as well. With this, we're actually going to start having fun and look at the testing, hopefully.
So we'll take a look at what we're going to set up. We're doing it in two parts. We're starting with a basic single site topology, and we'll walk through the configuration. And then we'll look at what we can do in a more complex multiple site topology where an organization has a HQ and multiple branch offices, which is really where we get a lot of pushback from Cisco people and any telephony provider in how we can do it, if we can do it in the right way and the best way, which we believe we can. So if you just take a look at the diagram for the single site, and in here we've got a Lync server with a co-located mediation service. The signaling will go from the Cisco call manager through the mediation service to the Lync server and then to the Lync endpoint. But the important thing is that the GSON11 traffic won't. It'll go direct between the Cisco MTP and the Lync endpoint, which means we're not putting any load on that server, we're not doing any transcoding or anything to do with it, which means we can start to co-locate those services on the same hardware as a Lync server while not impacting anything else on that Lync server, such as conference calls or anything like that. So we're going to do this in 3 stages. We'll just take a quick look at the setup. We've got 3 virtual machines, 3 virtual machines, the Active Directory server, the Lync server with the mediation service, and a Cisco call manager. And we're doing this on call manager 413 SR8, which is the most commonly deployed Cisco call manager, and it's a fairly old one. Plus, the later versions we can't run on Hyper-V, and I wasn't allowed to bring VMware on site.
The Uber point here is if we can do it on Core Manager 4, you can imagine it works on the other versions as well. If we'd shown it to you on version 8, there would have been questions as to whether it works on 4 or not. Yes, it does.
So anything 4 and above, we can do this with. Configuration changes slightly, but for all intents and purposes, the basics stay the same. So we're going to look at the Lync server configuration. We'll take a look at what's in the topology. We'll set up all the configuration using PowerShell, so I don't have to type anything, which is very good. And then we'll take a look at what we've done, and then we'll take a look at the Cisco side as well and add a few bits of configuration in there, and then we'll play some test calls. So if we just move over to the demo machine, which I think is this one. No. That one. So what we're going to do is we'll just run the PowerShell quickly through using remote PowerShell. The PowerShell script is in the back of the slide deck. It's in the backup slide section, which will be available to download probably in the next day or so as it gets uploaded. There's also step-by-step slides of all of this in there, so you can start to replicate this in your labs if you want to and go on from there. So as long as we don't see any red text on this, we should be good. And that is so much easier to do than having for me to type all that in. So if you take a look at what it's actually done, what we have is we have 2 dial plans. The US East one is used for users. It's used to translate extension numbers to E164 numbers. And we have the same one for the gateway. Now, this is an important one, as what it allows us to do is translate the 4-digit. This is used for inbound calls. So we're not having to do any translations on the Cisco side. The Cisco side can give us a 4-digit extension, and we'll translate it into E164, which really does simplify the configuration on the Cisco side. As prior to Lync, we had to do some of this work on the Cisco side, which did mean we got more pushback, made things more complex. We can do it all ourselves. So it can stay completely within the Lync server team. The voice policies, standard voice policy, pretty much everything's enabled, and the user can route any phone number. We route that to the Cisco Call Manager. And the only other thing to look at is slightly on the trunk configuration, as we do have a few things on here. We have MIDI bypass enabled, but we have refer disabled. And this is important because Cisco doesn't support refer in the same format as Microsoft require it. It doesn't cause us any limitations. We just can't select that checkbox. Otherwise, things won't work. And the other important thing is the associate translation rules. Now, these are used for outbound calls. So again, we can do this translation on the Lync side. So we can go from E164 down to the 4-digit extension. We can put a 9 in front for outbound dialing. We can do whatever we want. So again, it means we can do it all ourselves. It means there's no reliance on the Cisco environment to do anything. Cisco configuration is extraordinarily simple compared to this. So if we actually take a look at what we need to do on the Cisco side, we need to do 2 things. We need to create a trunk, which allows us to route the calls, and then some configuration on how we route it. And this probably brings some nightmares back for some people. It definitely does for me. The worst thing is when I have to install Server 2000, which is very painful. It involves things like floppy disks. Just wait for Java to spin up and the VM to spin up. Just going to create one trunk, which will be a SIP trunk. Told you typing was not a good idea for me. Unfortunately, there's no way to automate this. So you go through and set what we need to. Main things to remember on here is changing the ports as they're slightly different. 5068. They're not the standard ports. And just allow it to route calls back in. That's it for the trunk. There's not really isn't much to configure on there. Again, the Cisco, you may get pushback from the Cisco people, but creating a trunk is nothing new to them. They do it for all of their gateways and all of their configurations, so there should be no justification for pushback.
Doesn't mean there will be none.
So just politics is another matter completely. Just wait for the website to come alive. There's far too much Java in this version.
Yeah, we should have some music for Java there. So what he's doing is associating a route to the 8500 phone number. Of course, in real life, you would do it for more than just the 8500 phone number, yeah?
Yeah, it could be a lot more.
We're making it simple, yeah?
So we'll just sign out and sign back in again, as prior to running the PowerShell script, the user wasn't enabled for enterprise voice. So, Francois, if you could call
Adam Jones. Oh, that's
didn't
a
want
good
that to
start.
happen. Try it again.
Yep.
Uh-huh.
Okay.
What's the number on there? 8500?
8001. That's interesting. Okay, at least this works. Hello, Adam, can you hear me? Wow.
I hate demonstrations.
Yeah, it's the demo. It's the dreaded demo effect. It works all the time, but just not now. Okay.
I'll blame it on the Cisco side. There's actually a good chance I mistyped something. Let's have a quick look.
Yeah, the good thing about the PowerShell script is it's been tested before, so we know it works. So that cannot be the PowerShell script.
It should automatically do it in the root partitions added. You can reset it anyway. Let's just make sure this is all correct.
Happens every time, yeah?
It should be. Good news with the demonstration, as long as it's still working, we're not changing anything, so that should still be bulletproof, he says. No, I'll blame it on this.
Okay.
I'll blame it on the Cisco side. I don't want to spend too much time on this.
Well, hopefully we'll see something that works much better on the other side.
We did do this demo in Tekka and Mir, and amazingly it did actually work.
It's fun every time those things happen. Okay, so I'll take it back for a few minutes here. Okay, so when it comes to multiple sites, there's quite a few things that are different. Here what we had is just one instance of Cisco talking to one instance of Microsoft, and the clients would just go to the same media gateway all the time. Very simple for them to find that media gateway. Here what we have is a situation where there is a centralized signaling instance, that's the call manager itself. We actually have Cisco MTP. They could be sitting on an ISR router. We don't happen to have a router, so we have a software implementation, but it's the same thing. So you could have routers, ISRs in your branches running Cisco's MTPs. They might also have SRST to do observability if you happen to have that. And you have that in maybe 100 branches. And the last thing you want to do is to deploy mediation servers everywhere or to trombone everywhere. We can actually work in that circumstance. That's nothing particularly different for us. we can actually support that type of topology, which is centralized signaling and individual media gateways. The way we do this, and that's what Adam is going to show us in a few seconds, is rearranging cables, so that's why I'm kind of doing the dance and song here. So we'll define regions and site in network topology, same as mission control as mentioned before. We'll define media gateways. We're going to call them virtual. They're actually the MTPs. They are not the places where we're actually going to be sending the signaling. We're going to be sending the signaling to the main central instance, but we're going to define those media gateways in topology builder, and we're going to associate them with that representative media IP. As I mentioned before, we don't want to put the actual media IP there, or we don't have to. We might, but it's not really important. And that gives us the flexibility that the Cisco persons might change those IP addresses, re-IP it, or we might have multiple MTPs there, and one of them might be down and whatever. It's really not that important. We could have multiple MTPs or multiple ISRs in that one site, or you could have one in each and every site and so on, and we'll have representative media IP addresses for each. You can put the same one per site. It's fine. We will associate different listening ports, and that's kind of because of the way the PBX works. One little complexity, but nothing particularly complicated. And then we'll establish routing a little bit in the same way that it was just done by Adam on the single site type of topology. One interesting aspect is Lync knows where the Lync client is. The Lync server knows where the Lync client is. On the other hand, the Cisco system doesn't know where the Lync client is. So there is a preferred or recommended routing on the Cisco side, which is to exit from the Cisco side as quickly as possible, locally to the phone. If you have a local router, a local media gateway where the Cisco phone is, we recommend that you route the calls from that phone to that media gateway, which then would go to Lync, and then Lync knows where the Lync client is. That gives you more, that maximizes the number of cases where bypass will occur. In particular, if I took my Lync client, I'm no longer where I'm supposed to be. I happen to be where the Cisco phone is, even though the Cisco phone might think I'm still in the other site. In this case, we would have bypass. So that's one of the little tricks of the way this is implemented, and Adam has implemented it in that manner. With this, I think I'm going to take us through a couple of. Oh yes. So this is actually the association of the representative media IP. Sometimes we use alternate, sometimes we use representative. Don't know why we have those inconsistencies. But as you see, this is a generic media IP that's part of this subnet here. That's on the headquarter side. And every IP that fits within this subnet, this one does, will be associated with this site. So just by having done that, we know that this specific virtual gateway, which is here, which is an MTP, will be in this site. And the other one here, which happens to be in Atlanta, would be on the subnet that's associated with, in the network configuration, with the Atlanta site. And then we know that we can do bypass for that site. Good? Great.
Partially.
So let me tell you through a couple of things that we're going to demonstrate for you. The first one, actually, I'm not sure whether we'll do it in this order, so let's not say first one, but one of them is I have a branch, the Atlanta branch. I have some Cisco infrastructure, Cisco endpoints, and ISR with an MTP. Might have more, but that's all I need. And I have a Lync client. This is an interesting situation. If your WAN is sufficiently resilient, or if initially you don't care as much about resiliency of the WAN, you can actually deploy in that branch office by just dropping the Lync clients. And you will be able to keep the media local, no hardware, or no incremental hardware, no incremental software. We will show that you can actually also have a survivable branch appliance in a short while, but you can actually start your deployment with this just clients, and it's actually going to work and keep the media local and have a number of interesting aspects. Even if you were to lose your WAN, after the call has been established, there is no more signaling to the servers, but the call stays up, and we're going to demonstrate that. This is actually quite interesting type of situation. Of course, that client will be unregistered at that point, doesn't contact us anymore, but you can still have that call up. And if this was your PSTN egress, the call to the PSTN would also be up. Okay? The other type of calls we're going to show you as calls that are not going to bypass. This one doesn't bypass. Why? Because this client and this MTP are not in the same site. This call from the Lync client to this phone would be associated to this MTP and doesn't bypass. You could actually associate it with this MTP if you wanted to, but that's not very likely to be the case in this situation. And then bypass here, but then you would have Cisco flow to that phone. So it's a question of how it's done in the Cisco side. So we'll demonstrate those two types of calls that bypass, calls that don't bypass. With this, I think, Maestro, it's all yours.
Excellent.
Okay.
So what we have here is two sites. We've got the HQ site, and we've got Atlanta. In the HQ site, we have the Cisco Call Manager with an associated MTP, and we also have a Cisco IP phone. In the Atlanta site, we've got the Cisco MTP, the Cisco IP phone. But what the Lync client's actually been moved to the HQ site. They have a failure of the DHCP server in the Atlanta site, so they've moved to the HQ, which luckily is down the road. So if you take a look at what we have on the demonstration side, we got the Lync client, and I've fired up a wire trace from the mediation server. And this is so we can actually see if media is bypassing or isn't bypassing. If it's a non-bypass scenario, we'll see a lot of UDP packets going through the mediation server as it transcodes from RT audio to G711 and breaks out that way. So the first scenario we're going to look at is the Atlanta user calling a person in the Atlanta user in the headquarters calling someone in Atlanta. This becomes a non-bypass call purely because we know we can tell that the Lync user has moved. We can dynamically calculate the bypass ID. We know they've moved network. Therefore, we can choose whether we bypass or not. And we don't actually want to bypass. We want to put as little load on the network as possible. So, if you can answer the phone for us, well, hopefully.
Hello there.
We see a lot of UDP packets. So all we actually see here is this is a non-bypass call. And the call leg for this is the Lync user in the HQ going to the mediation server, then the mediation server going to the Cisco phone in Atlanta via the MTPs in the HQ.
You're speaking in my ear.
Excellent. I'm always a flea in your ear. If you look at the inverse of that, of calling a HQ user, this scenario we don't get bypassed because we're on the same LAN. We don't want to use RT audio. So managed LAN, we can use G711 without any issues. This can be quality of service marked if we need to, depending on the LAN configuration, and we can keep everything within that site. And as we can see, it's not going through the mediation server.
So it's a bypass call. Are you pulling the Lync now or later?
So if we just want, let's just make sure it works the other way around, and we'll get the Cisco people to call us. So if you want to call me from the HQ site, Francois?
Yes, here you go. If I press the right button, yeah. By the way, you see the names, indication, and so on, so very smooth, huh?
So what we see here is, again, this is a non-bypass call. We wouldn't want it to bypass. It's saying within the same site. And if we just try the same from the Atlanta Cisco
It is
user?
a bypass call. Yeah, I'm not sure whether you said it right
It
or
is,
whether
yeah.
I heard it wrong or whatever. It is a bypass call.
If you want to try from Atlanta, Francois? And again, this becomes a bypass call. Non-bypass. Everything's going through this. And the good thing is we can do it from both sides. It doesn't matter where the user is in this scenario. We will work it out if necessary. If the user is accessed through the edge server, again, we don't bypass. We can use the correct MTPs, and we route the call correctly. The only time we run into an issue is if a Cisco phone is moved, as there's no dynamic nature to the Cisco side. We have no way of telling where that phone's moved to. Indeed, even the Cisco administrator doesn't know where that phone's moved to, which is why when it comes to things like desk moves, even though it's easier than moving TDM phones, moving IP phones can still be a pain, depending on how you segregate your network. The last thing I want to prove is that this really does bypass, and this isn't smoke and mirrors, but it has to be the last demo because it breaks everything.
We're going to kill the mediation service. Actually, more than that, going to kill the NICs on the front ends. So
Francois, if you call me from the HQ phone, please.
from the HQ. Are you in the HQ?
I'm in the HQ.
Okay.
Let's see how destructive we can be.
This is the machine that has the front end, standard edition server, and the mediation service on it. And we're looking at the NIC right now, and something really bad is going to happen to that NIC.
And that's died. Completely. That's why I need to do the last demo. I can't re-enable it. And we still have surviving of the voice because we're not going through the mediation server. We still, call control we don't have either, as we completely severed that link. But at least we can finish our conversation without it just being bluntly cut off. So in a WAN scenario situation, if the WAN link was to go down, we could still continue with the voice calls we're having at the moment without it being cut off, which is definitely a better solution than just terminating all calls at any one point.
Okay, so yeah, actually. So what you've seen is actually, for one thing, it's the first time that it's been shown publicly, to my knowledge. It's not the first implementation ever, but it's the first time that type of demo has been shown and done publicly in real time. It's not a very simple thing, and Adam has an absolutely fantastic job in this. That documentation, to a large extent, is in the slide deck as well, and there's a white paper forthcoming. And you've seen essentially, without any sort of smokes and mirrors, well, at least as far as I know, and maybe you smoked me as well, that you can actually have complete bypass situations in a multi-site environment. This is a relatively simple multi-site. It's one headquarter, one branch, but you could multiply it. Optimizes traffic in the branch, optimizes traffic on the network, provides incremental resiliency. You've seen what happens. You lose, in this case, completely Lync, the server, and it still continues to work, not just a mediation server. Okay. There's one more layer to this, which is that we said earlier that if you were to lose your WAN, the calls that were up would stay up. But of course, you would not be able to establish new calls. There is a variation on this where you could put a survivable branch appliance if your WAN is not resilient. So you can drop a survivable branch appliance, which is an appliance from our partners, that, as I showed you earlier. And you can bypass in this situation as well, which enables the survivable branch appliance to not to have to be scaled to support transcoding on each and every call. It's a significant advantage because you can actually support more people in that situation with that appliance than if you were to transcode each and every call. So that's in terms of what you can achieve in this circumstance. With those type of capabilities, you now have the opportunity to coexist with an IPPBX, a Cisco in this case, and with that implementation, with very little or no incremental hardware in place, depending on what you want to achieve and what type of resiliency you want to have and so on. And you can actually have a coexistence and migration strategy that's based on that. You can actually have an on-net type of routing capability that's based on a SIP trunk between Lync and the call manager, and then you'll do media bypass to the endpoints here. You can have an off-net routing strategy to the ISR, where you're going to actually route your PSTN calls there and have ingress calls go this way and that way and so on. And that's something that's very easy to put in place that then enable you to progressively migrate users. And partners such as Adam are capable of helping you in this type of situation, having very complex charts like this one that actually express that very simple thing I was showing on the board before, essentially just stepwise migration in a coexistence mode. We now have dozens upon dozens of customers in that type of situation today. With this concludes the prepared part of the presentation with those brief takeaways, and then we'll have a little bit of time, about 10 minutes for questions. Integrating natively with IPPBX, first, it's feasible. And you've seen it with Cisco. You've seen it. It's not that difficult to provision, even though we had gremlins today a little bit. It's absolutely feasible. You have a lot of reference material on that. It can actually be done at relatively low cost, very little hardware, or just the required amount of hardware to put in place. And you can have a coexistence strategy and a migration strategy that's very effective and that enables you to also optimize your media flows. All of this is available, documented, works as you've seen, and we can help you in that process, and our partners such as Adam can help you in that process. Thank you very much, and we'll move on to questions. If you don't mind going to the microphone, please. Well, by the way, we do have goodies, as usual. We'll decide who's deserved some of the bacon stuff and some of the better goodies, too.
If I have a Nortel, or Navia, sorry, Navia PBX, do I need a secondary piece on the Avaya PBX to get presence?
So there's several questions in what you're asking. The first question is around Avaya/Nortel PBXs and how to interoperate with that. And then there's something around scenario and presence. I would refer you to the OIP page with respect to what's supported in what manner. When it comes to specific PBXs that are a little bit older, we had a session earlier, we spoke about some Siemens and other. My preference and my recommendation is to look at, unless it's really not feasible for you, to look at gateway-based interop, even though direct SIP might be possible. And the reason for that is that there are some advanced capabilities that the gateway partners would support better than direct SIP is capable of doing it with some of these older PBXs that are less SIP capable. With respect to presence, I assume you're talking about presence of the phone line. And that's very different from what you've seen here. What you've seen here is somebody on a Cisco phone talking to somebody on Lync. It's not, I'm on Lync, but not for telephony, and I'm picking up my Avaya phone, and I want to see my presence reflect that. We do have solutions that enable that today. One of them is called remote call control. I happen to not feel good about recommending that one. And it's there, it's available, it's supported. So if you want to do it, partners will help you install it. My opinion is it's probably not the most strategic way for you to progress. We also have solutions in preparation that have been pre-announced that will enable through a trusted server intermediation when you pick up your Avaya phone without using remote call control to see the presence change on Lync. And that's what I would rather recommend. That's not yet available. It's been announced. It's coming.
So if I have a SIP trunking for inbound trunking instead of PSTN trunks, and say I wanted to use something like an SBC, like say a Sonos PSX, instead of ISR in a coexisting scenario, is there any caveats to that I should think about?
So external SIP trunking is something on which we don't support a media bypass. Okay. And one of the reasons is the media healing that I described. Another reason is probably linked to security as well. And we do recommend using mediation servers for that. Now, typically when you do SIP trunking, it's going to be in a centralized location. And you can actually afford, there's cost, but you can practically manage having mediation servers there. There is one caveat, which is that if you want to do SIP trunking at the branch level, we have support through our partners in the SBA for that. So you could actually use an SBA there as well and terminate it there. You added the point of the SBC. And if you want to use an SBC, well, that's okay, and we have no configuration notes for that. We don't believe you need one for that. And our recommendation in our topology don't include an SBC for that.
Okay.
So in this interop mode, can you actually do call forking from Lync to the actual handset itself?
So in terms of the Lync client ringing and the IP phone ringing
yes.
At the same time?
Yeah.
So this is a very different type of question you're asking. Now you're asking belts and suspenders per user type of question. In what we showed you, some users had a belt, other users had suspenders. All the pants were up. And that worked. Now you're saying, I want both. So we used to have a supported configuration for that called dual forking. And that was in OCS 2007. We don't have that anymore. There's a number of reasons for that. One of them is that pretty much nobody did their, it required two vendors to work jointly towards a solution. And apart from Nortel, which we had a partnership with, unfortunately no longer there, nobody else did it. So we actually pulled that thing. The other reason is that the scenarios become very complex. I'll give you an example. Boss admin type of scenarios. If you have a boss on a boss and an admin both in the same situation and a call comes in, they could end up being on different systems, and those advanced scenarios will be broken. So we don't support it out of the box anymore. You can build it if you want, and you could build it including with those type of things that we've seen here today. I tend to not really recommend that because, in my view, at some point you have to make a choice. If you think Lync is good enough for you, just use Lync. When people are uncomfortable moving to Lync all at once, my recommendation is to use forwarding. Take your Cisco line, permanently forward it to Lync. Make it transparent, and that's easy. We can help you do that. We have some indication on how to do that. You no longer have the confusion of it's ringing both sides, I don't know what happens, or I'm traveling and my phone is ringing all the time and my colleagues are getting completely nuts because it's ringing in my cubicle all the time. Lots of advantages like this, and it's much more predictable. So there's workarounds to the forking. Forking tends to be a messy thing. But if you want to do it, you can. There's people doing it, and partners can help you do that. Absolutely.
Okay, thanks.
My question is a little bit backwards in terms of interoperability. What are the options for Lync for messaging / voicemail outside of Exchange? Are there any? Is there any operability there?
You want to take that answer?
Oh, I would get the... why do I always get the horrible ones? The initial answer is not exactly. Lync can only really forward to Exchange OM. There is a possibility for a third party to write an integration. I don't know of any of them doing that. There's no real secrets in there. Exchange uses UCMA2 to integrate. So there's no reason why they can't do it. I just know no one who has done it so far.
We're good? Oh, yes?
When you're running a Lync call,
I'm sorry, I missed the beginning.
if you start a Lync session and I say I want to share my content, what's the maximum frame rate I can get?
I am not sure I know the answer to that. I have to say, you know that? 3,500 is the answer.
3,500 frames per second?
I have no idea. I mean, I'm literally, that sounds like a lot, but.
Yeah.
Yeah, actually, it's RDP. So whatever RDP does, which is not really frames anyway, but it's RDP. It's RDP. Whatever RDP documentation is. Would you agree?
Yeah, more bandwidth for faster
Yeah.
Jumping back to video.
Yep.
So you showed us the solution for RAD vision, and you also mentioned Polycom uses a slightly different approach.
Yes.
Can you just spend a minute to talk through how Polycom's different?
So yes, how Polycom's different. So Polycom.
If you bring that diagram back up.
Yes. Do you mind bringing that back up? Yeah, Polycom. Actually, we do have a Polycom chart that just was hidden. There's a lot of hidden charts in the deck because we didn't have quite enough time to cover everything. Just a little bit more. That one. Yeah. Okay. You want to bring it up? So Polycom, in particular, implements endpoint direct registration. That's one of the ways in which they're different. So in this case, what you're looking at is an endpoint. So we're going to say this could be a Polycom endpoint, and this could be a Polycom endpoint here. It's not necessarily unique to Polycom, by the way, but I'm going to talk about it as Polycom, but it doesn't have to be unique to Polycom. And what you have is the ability for that endpoint to register to the Lync server directly, and then to act as if it was a Lync instance. You see a Lync client here. This looks like a Lync client. It behaves like a Lync client. It actually can go into conference mode with CCCP and use media on the MCU. And it could actually, if it was outside at another vendor or the other customer federated with you, use federation through the edge and participate in the same conference here. So you could actually have all those things as if it was a Lync client. That chart, in a way, is not very spectacular because you replace VTC with Lync, and it's like, so what, But that's part of the point.
So what are you giving up by doing this versus the RAD vision solution?
So the advantage of doing this, if you have the right gear, is that it's completely native, so you don't need an intermediation gateway. And gateways are great and they help a lot, but they eventually cost a little bit of money. So that's one of the advantages.
Any downsides?
I'm sorry?
Are there any downsides to that?
To
this approach versus the RAD vision?
Downsides.
Multi-point?
I'm not sure. It depends on the circumstance. Once it's in that mode, that endpoint now registers to Lync. So if you wanted to register to the traditional VTC system, you need to change it. And if you wanted to now participate in a hardware MCU-based conversation, but there's no real catastrophic downside I can think of.
Yeah,
Okay, I guess I got two quick questions trying to clarify some things. One, when it comes to the Polycom roundtables, are the Polycom roundtables actually set up to be Lync clients themselves directly?
No, they require a USB connection to another Lync client. Polycom have a roadmap around them. It's not something we can share today, I don't believe. I would say go and speak to them at the expo, but they've left by now. There might have been a pub somewhere nearby, but so the answer is no, you still need a USB client.
They're just like this one.
Right. And
A
that's
little
how
bit
we
smaller,
use it
but
today.
just like this one.
Yeah. And then on the second side, I saw the Audio Codes Gateway is one of the premier partners, and we're looking at, my company's actually in the middle. I left in a good week. They're putting in a ShoreTel VoIP system with Audio Codes Gateway so that we could connect our current OCS system, but I'm actually thinking about dumping my OCS for Lync next week.
Good. Good move.
So because it's the premier partner, we would get the media bypass and all that, and something we just bought an Audio Codes Gateway literally this week. So
depending on which exact version of Audio Codes Gateway we're talking about, but assuming this is the same thing, same type of software, it supports media bypass.
Excellent.
Of course, there's a question as to why you would want to put a ShoreTel in the first place, but you get a consolation prize.
So two completely different questions and on things that you didn't really bring up very much, but I'm just curious, is Microsoft doing anything on the roadmap with Lync as far as fixed mobile convergence goes?
Fixed mobile convergence. So you're asking a question about roadmaps, so it's a little bit tricky.
I understand.
Yeah. And it's not the first time you do this. So fixed mobile convergence is something that has multiple definitions. Today, you can already forward your calls to, and so on. If you're talking about having what we call call from work, single number reach, we used to have something like this in OCS 2007 R2. Right now, we're looking at something slightly, different. But when we're going to be coming up with the mobile clients at the end of this year, you should anticipate there's going to be something in that space. Eventually, however, what we want to have is capabilities like voice over IP and video over IP and those kind of things on mobile devices. Mm-hmm. At that point, it's not a fixed mobile convergence anymore. It's just another Lync client. Okay? Fixed mobile convergence would almost disappear at that point. You don't need to have a fixed mobile convergence concept because it's like gluing things that are different. It would become a unified thing from the start.
Sure. And the other question concerns codecs, the SVC codec. Can you just say a few words about how you see that easing integration in the future?
Yes, so the scalable video codec, H.264 scalable video codec, is a relatively new codec. It's been around for a little bit more than 2 years, but in practical terms in the market, I think 2 years is about the time that people have really started taking notice and that it's really been getting traction. If we had SVC 5 or 6 years ago, it's very likely we would have taken SVC from the start instead of RT video. H.264 sounds like the same thing, but there is a huge difference between baseline profile and SVC. And SVC is very resilient on the internet, a little bit like RT video is. What we've decided to do is that we're going to migrate to SVC in the future that's been announced. One of the advantages is that everybody who uses H.264, including baseline, will have the ability to interoperate without transcoding with SVC. And there's also there's a lot of stuff in the press that you'll see that people are going to put SVC or at least H.264 in hardware, in CPUs, in GPUs, in webcams. That means that doing high-definition video will become possible on almost any endpoint because your CPU, your GPU, or your webcam will have that ability to do the acceleration. At that point, any, not just a PC, but tablet, whatever, will be able to do high definition, probably full 1080, and Lync conceptually could support all of that.
On the,
you do get a webcam for your efforts on SVC. Okay, will be for you.
On the certified, on the certified SPAs, is there an expectation, at least a Microsoft expectation, that they have some sort of mediation component built in, or is it a leeway, sort of open-ended, where they would force media bypass to that device at that time?
No, that's a very good question, actually. There's very specific and strict requirements for the SBA. Actually, somebody here has been going through them quite a bit. Yes, there is the capability the full capability of the mediation server. It's just that it's not scaled as a mediation server that would just be a mediation server. So media bypass is part of the assumptions that participate in the design and the scaling of the SBA. But yes, if there is transcoding required, it can do the transcoding. You may want to say a few more words.
It really comes down to the power of the SBA. A lot of the SBAs have got very small CPUs, so you don't want to do too much transcoding because you won't be able to do too many calls. So they'll tell you, oh, you can't actually do transcoding and the mediation server because it's going to restrict the number of calls that's something to do. You go with some of the, you can come speak to me, I won't name drop, but we have a bigger CPU in ours, so you can try and do that.
So that's Kevin Isaacs from NET, one of the partners. Hey, we love all of our children. So the short answer is, as you do your planning for the SBA, and as you select the SBA, not just the vendor, but the specific SBA you're looking at, you need to understand. It would be a good thing to have an understanding of the type of profiles of calls you're going to be looking at.
Thank you.
You get something. Come over. More questions? Still have some goodies. We are out of time, obviously, but are you already doing enterprise voice or not? Yes? You're doing enterprise voice? Then you gain this. Thank you very much.